Hi guys, I'm here to go through our waves vocabulary notes day 2. So you guys need to read through the slides and or watch this video to understand the content. So today we'll go through some new different waves vocabulary notes from the ones we did on Monday. So today we're talking about the different properties of a wave. Properties of a wave. So properties are the ways to describe the wave. Another word you can think about for property is characteristic. So like the characteristics of the wave. So how do we describe it? So there are 4 different properties that we talk about. So one of them is amplitude. Another is wavelength. Another is frequency. And the last one we're going to be talking about is speed. In this picture here, you can see this is a longitudinal wave versus a transverse wave. So in the picture, try to identify, where do you see these words come up on the picture? I will give you a moment to find them. So the first word that I noticed was wavelength. So I see wavelength here at the top on the longitudinal wave, here pointing at the wave. And I also see wavelength over here, pointing from here to here. I also see this first word, amplitude. I see it right here. I see it's pointing to this red line. And I also see it right here inside of the wave and going up and down. Okay. So, and I don't see the frequency and speed words on this picture. So let's go through and learn about our amplitude. So amplitude is the distance. These red words are the words you need to write down. So you need to write down distance. Amplitude is the distance from the rest position of the wave to a crest or a trough. So remember, in our last set of vocabulary notes, we talked about the crest and the trough. If you don't remember those, please go back and look at those notes. Remember, a crest is the highest point of a wave, and the trough is the lowest point of the wave. So the amplitude is the distance, or how far it is from the rest position to either the crest or the trough. So let's look at this picture. So this black line here, that is our rest position. So our amplitude is from the rest position to the crest. So that would be the top right here, because that's the highest point. So how far this is, this distance, that would be our amplitude. And it's also the same if we look at a trough, because the rest position is in the exact middle. So these distances are the same. So they are our amplitudes. So we go from the rest position to the trough. Here you can see our nice GIF showing us that it can be either one, either to the crest or to the trough. Okay, so next let's talk about some wavelengths. So wavelength is the distance between two identical parts of a wave. The wavelength is the distance between two identical parts of a wave. So here you can see that the arrow, it starts here at the crest and is going to the next crest. So from one crest to the next crest would be one wavelength. Okay, so here on this other picture, we can see that, again, we're going from the crest to the crest, and this is a longer wavelength compared to the bottom one, which is a shorter wavelength. See how we're still going from crest to crest, but our distance is shorter, so it is a shorter wavelength. Up here we have a longer one, up here we have a shorter one. So when we look at the wavelength on a transverse wave, on transverse, wavelengths are measured from crest to crest or measured from trough to trough. So here we're going from crest to crest, or if we could see the rest of the wave, we can go from here, from trough to trough. Okay, crest to crest, trough to trough. That distance in between those two, either crests or troughs, are our wavelength. That's how long our wavelength is. Now let's look at the wavelength on a longitudinal wave. So longitudinal wavelengths are measured from compression to compression. Remember, compression is where they are close together, or from refraction to refraction. So refractions when they're from where they're farther or more spread apart. So here in our picture, it's not lined up exactly perfect, but here we're going from compression where they're close together to the next compression where they're close together. Or if we wanted to measure from refraction to refraction, we can go from this line to this line, because it's the same place in our refractions. Okay. So next, let's talk about our frequency. So frequency is the number of waves that pass a point per second. So how many waves are passing in 1 second? We have a unit that we use for that, which is pronounced hertz, which we abbreviate as Hz. So frequency is how many waves are passing in 1 second, and we measure that in hertz. So for example, we could have 1 hertz, 2 hertz, all the way up to 1,000,000 hertz, depending on how fast that wave is. So when we have high frequencies, we have shorter wavelengths. So let's look at this picture. So this is an example of a wave that has a high frequency. And look, when we go from crest to crest, that distance is really short. When we go, if we look at the next example, it has low frequency, which means we have long wavelengths. So our low frequency here, if we look at our crest, if we're going from crest to crest, this distance is much longer than the one up here. It's almost probably 3 times longer. So our frequency is much lower. Maybe here we can only get from here to here in 1 second, or here maybe we get from here to there in 0.2 seconds, right? So think about high frequency and low frequency of how many waves are passing per second. So when we can also figure out the wave speed. So wave speed is how fast the wave is traveling, or how fast the wave travels. So we do calculate our wave speed, and we have a formula here, which you can see. So wave speed equals our wavelength times or multiplying by our frequency. So let's look at this picture to figure out how we can calculate its wave speed. So here at the top, the first thing I notice is our waves are labeled. So we have wave 1, wave 2, and wave 3. So we have 3 waves that are passing in 1 second, according to the stopwatch. So 3 waves in 1 second means we have 3 hertz, okay? So our frequency is 3 hertz because 3 waves are passing in 1 second, okay? So we have our frequency. Now we need to find our wavelength. So down here, our wavelength is given to us. So from crest to crest is 0.5 meters, or half a meter. Okay, so let's look at this problem. So in green, we can see our wavelength is 0.5 meters. We figured that out from the picture telling us that. And then we have our frequency of 3 hertz, which was at the top. So then remember, our formula is wavelength times frequency equals our wave speed. So we plug in those numbers. 0.5 meters times 3 hertz equals 1.5 meters per second. So our speed of our wave is 1.5 meters per second. Remember, on your note sheet, you had to write down the red words, but you also need to write down this example. Okay? So, look at your note sheet and fill this in. Let's look at one more example together. So, on our picture, we can see, so it says for us that we need to count the waves that pass in 1 second. Remember, we can go from crest to crest. That equals 1 wave. So, right here it tells us that our 1 second line is this green button. So how many waves are passing? We have from crest to crest. So we have 1, 2, 3. So our frequency is 3 hertz because we have 1, 2, 3 waves that have passed in this 1 second of time. Our wavelength is given to us because we can't measure this picture. So our wavelength is 0.2 meters. So if I plug in our formula of wavelength times frequency equals our wave speed, we go from 0.2 meters times 3 hertz, and that equals 0.6 meters per second. Nice job. You guys have now come to the end of the slides. If you have any questions or are confused about anything, please email Miss Kristen or Miss Linnea, or as always, you can join our Google Meets call that is open in the mornings and sometimes in the afternoon. We hope you guys have a good day. We hope to see or talk to you soon.